Hello and welcome, guys. So just got done with class. I wanted to uh, recap on a couple things about Newton's method as a new topic for you guys. So hopefully you were able to get a sense of what was going on in class, and at least be able to work these out numerically. But I just wanted to show you graphically what's happening to the function um, when we're doing this. Okay, so we're using the derivative and tangent lines to essentially um, use to find values for these roots, right? So let's say you have f of x equals cosine x plus x squared minus 5. By the way, I'll link this Desmos so you could have a play around with it. You can manipulate the function and change it up, so you can have a mess around with it. Um, but yeah, so I have this function here, and usually the motivation behind this is called a numerical method, because we're trying to find this value numerically, because through normal means we don't really know how to do it. There are, eh, like the square root example we did in class. We do we don't have we know what the answer is. We know that it's square root 11, but we don't know what it is exactly, right? Numerically. So we have f of x being this function, and let's say we want to know the value of this root here. Okay. So we've got that. What we're going to do is take an initial guess. So uh, we're going to see if I'm going to guess I'm trying to find this root over here. So let's make our initial guess maybe -2. That makes sense, right? So it's pretty close to the root. I can kind of verify that graphically, right? So the first iteration pops up. So we're doing, we're finding this tangent line at f of -2. It draws in that tangent line. And now here's my new value. This is my new value because that's where it crosses. Okay. So then they go and a, they take a tangent line at this value. Okay. So let me zoom out a little bit. This new value. And you can see that tangent line becomes even better. It's even closer. I mean, it's almost right on it, on that root. Okay. And you can imagine if I do a third iteration, wow. So that one's come up and made a new tangent line, and that one really is hard to distinguish between the actual root. Okay. And if you go for the fourth and the fifth, I mean, you're basically just putting them on top of each other. You can see that the calculator also, um, so it does that little iteration for us, and up to 5 iterations, we've gotten that. Okay, so now let's zoom out. Let's hit the home button. And so let's say we took a bad guess. Okay, like I said in class, there are bad guesses you could make. Now it looks like there's a stationary point, a maximum or a minimum down here. So in that case, let's say I guessed 0.1. Okay, and you can see just it gets a bit wild. Its first guess was way out here. Let me kind of hide these ones. So its first guess is way out here. Okay, it barely even knows what's going on with the function, right? So that tangent line is not going to give me much good. But the amazing thing is actually it start coming back in. Okay, so then it does that. Um, and let's see, it's another one. Okay, it's getting closer. Another one, decently close. And in fact, it actually does look like this one is converging, just very slowly. if I did something like 0, I mean, it doesn't know what to do because it doesn't have an x to hook onto the x-axis. All right, so it's undefined. Curious how close you could get. So 0.01, that seems like it's too far away, but it does seem like it's hopping back just very slowly. So maybe as that series goes on, it will converge. It's hard to say, but for our purposes, knowing that uh, taking an initial guess near a stationary point of on the graph, uh, that is usually a bad idea. Okay. All right, I'm going to leave this here. Thank you for watching. If you have any questions on Newton's method, just let me know in class and we will go over it. And we'll be talking about derivatives and, or not derivatives, integrals and all that coming up. So take care. Hope you have a great day. See you later.